So this is tRNA activation. So in order for a translation to happen, you need tRNA. What is tRNA? tRNA is a transfer molecule. It transfers the amino acids into the ribosomes so that you can have the polypeptide chain. Right, so this is the structure of a simplified tRNA. There's a 3' side, which is where the amino acid would attach, and it also has on the very end, but kind of like the middle of it because it's bent, it's the anticodon. Anticodon will match up with the codon for the mRNA on the bottom. All right, so in this example, the anticodon codes for UAC, which in turn is AUG, which is methionine. All right, so that's the starting codon. Now, in order for the tRNA molecule to be used for translation, it needs to be charged. And in order to be charged, it needs an enzyme, a very important enzyme called aminoacidyl tRNA synthase. Right? This enzyme will bind with the amino acid and the tRNA using ATP to charge the tRNA molecule. All right, now first, the ATP, which is adenosine triphosphate, because it has 3 phosphate groups, will bind at the active site with amino acid on the other side on the enzyme. So this is the enzyme. And the ATP will be here, and the amino acid, methionine, will be here. Now, in order to bind ATP with the amino acid, ATP loses or discharges 2 phosphate groups. Now, when discharging the 2 phosphate group, it creates a release of energy that creates a very, very strong bond between the amino acid and the now AMP, adenosine monophosphate, because it only has 1 phosphate group. Now that it's bounded to the amino acid, it's amino acid monophosphate. Now the tRNA can come in, the specific tRNA that fits with the specific enzyme. So there's enzymes for each of the anticodon tRNA. So the tRNA comes in and it sets itself right in here because it's specific to that anticodon on the bottom. And right here, now we need to have this amino acid bond to the 3' prime of the tRNA. Once it covalently bonds with it, AMP is going to be discharged or released from the enzyme. So AMP releases from the enzyme, and the release of AMP is phosphorylation, which then makes charges or transfer the energy to the amino acid and the tRNA. This thus makes the tRNA that is used for translation. So here's the tRNA simplified with the anticodon, right? And the addition of this would be the amino acid methionine. Now this tRNA is charged, it's ready to go. It can go find the ribosome, fits into the ribosome, and create a polypeptide group.